Hi, everyone. Thank you for joining Digi Tutorials as we expand on part 2 of our review on functions. So we're going to dive right into how to determine whether a relation is a function or not. As you can see by the red lines, we have a vertical line test, and the vertical line test is running through the graph on the sheet, and what that line is doing, it's determining whether the graph is a function or not. And so if only one value of y can be found for every value of x, then we know that that relation is a function. But if the reverse is true, then it's not a function. So in the first graph, we can see that it's not a function because the vertical red line here intersected in more than one location. So it's intersecting the graph in more than one location on the positive side above and in the negative quadrant below. On the second graph, we have a semicircle here. It's not fully drawn properly, but you get the idea. You have the red vertical line running parallel to the y-axis. And since it intersects the graph in only one location right here, then you can tell that this is a function. So let's go into the second portion of this review. So here we have examples of relations. We have the function, whether it is or not, and the reason why it is or not. So the first set we have are ordered pairs. So these ordered pairs, as I said in the previous session, these are coordinates. So we have x, which is the first coordinate, first number or first character, which is the first item before the comma. Those are x values, and then the second are y values. So we know that the x is the domain, and then the y is the range. So here we have 2, 3, 4, and 5. Those are the domain, and then 3, 5, 6, and 8. Those are the range. So in this case, the reason why it's a function is because each value in the domain has a unique value in range. Okay, you can see that 2, 3, 3, 5, 4, 6, 5, 8. They're unique. There's no repetition here. In the second group, we have 1, 3, 2, 4, 3, 5, and 1, 6. So is it a function? No. And the reason is because when x is equal to 1, there are more than one value of y. Okay, so you can see when x is 1, y is 3 here. And then when x is 1, y is 6 over here. So which means this is not a function. And going back to how we can determine whether a function is a function is exactly why. As we said, if there are more than one values for y, then it is not a function. So when we look at equations, we can tell the same story. So in this case, y equal to x plus 1. It is a function because each value in the domain has exactly one value for y. So as x increases, y increases. And as you can see, say, for example, x was 1 here, then 2 times 1 is 2 plus 1 is 5. That means y will be equal to 5. And it increases as x increases. So y increases as x increases, which means each value in the domain will only have one value in the range. So each value of x will only have one value for y, which means it's a function. So let's move on. So this x squared plus y squared equal 1, it is not. And the reason is because you might have a negative in here or a positive or a negative in here. And when you have a negative times a negative, it becomes a positive. And a negative and a positive times a positive will give you the same answer. So there's more than one value of for y, even though they're all values, two values of x. So whenever the value of y is duplicated, whether it's a negative or a positive, then that would change the value. So which means you can have more than one value for y. And that's the reason why it's not a function. And if you don't understand, you can just plug numbers in. You can even use these amounts that we have in the ordered pairs, and then you can plug that in. And you could also change it up to negative values, and then you'll see how it works. In this graph, y equals half x squared plus 1. Okay, so it's half x squared plus 1. This is a function because remember when we did the one above, we did identify that because it's whether it's going this way or whether it's going the opposite way, when you do the vertical test, you know it's a function right away. So without even testing the values of y, you can determine that it is a function based on the way the graph is situated. And again, this is just a depiction of whether you plug in the values of y, that this graph will be not a function. Okay, because there are two values of y for each value where x is greater than 1. And I should have that there. So where x is greater than 1. Okay. Okay. So there are two values of y for each value where x is greater than 1. Okay. So let's review the function, how it operates. So when f of x, for all value of f of x, and in here, f of x are usually y value, x values inside the bracket. Excuse me. So whenever you have values in the bracket, they are always x values. So I can simply just put x at the top. And every time you have a function like this, it's usually x in there. So here we say when x is 2, y is equal to 3. So basically we're saying here the function of x, of f, maps 2 to 3 every time. And similarly for when x is -1, y is positive 2, which means it maps the -1 to 2, and x is mapped to y. And that's basically what that is saying. And we can prove that in our examples down here. So if we say function of x is equal to 2x minus 7, whenever we plug the value of x in the bracket, then we will find a solution to that problem, because we know we already got the equation here and we're just plugging in the value for x inside the equation to solve that equation. So you can see on the right, we have 2, and then we substitute the x, the 3 for the x, and then we subtract 7. So 2 times 3 is 6, minus 7 is -1. And as we go, we can see the same principle apply because we're always using this equation here on the left, which is 2x minus 7. Again, f of x plus 1, we substitute the x plus 1 in the equation, and then we solve. And bear in mind that whenever we do brackets, we have to be careful of the sign outside. And when we have 2 times x, we have to factor in both items. So we say 2 times x, right? And then 2 times 1, which is 2x plus 2. And then that 2 minus 7 will get you to -5, which hence why we have 2x minus 5. So now below, we have f of x equals x squared plus x. So what that is telling us is that this, any value we put in here, when we plug it in and substitute x in both parts of the equation or the expression, then we'll be able to solve. So here we have -2 as the value. So we're going to plug in -2 everywhere we see x. So because again, -2 times -2 is a positive, which means it becomes a +4. And then -2, it remains because -2, when you have a positive and a negative, regardless of whether it's beside a bracket or not, the negative overpowers the positive, which means it becomes -1. So therefore, if you were to plug everything in the equation, you're going to get 4 minus 2 minus 1. And that will become 1. Because it's basically saying 4 minus 3, right? Because -2 minus 1 is -3. Again, f of x plus 1. So we're going to plug in every value of x. So we're basically duplicating our efforts because we're putting in x plus 1 in place of x. So here we're going to end up with a factor, the 2 factors of x plus 1. And remember, we have to do our factorization in order. So we're going to have the x times x, which is x squared, which is why we have that here. And then we're going to have 1x here, plus another 1x when we multiply that here. And then we had another x here. That's why we end up with the 3x right here. And then we're going to multiply 1 and 1. So 1 times 1 is equal to 1. But we also have x here, another x plus 1. And I should have had -1 next to it because we also have a -1. Okay, so you have a -1 over here, then you have a +1 here, which makes that 0, and then only 1 remains. That's why the answer is x squared plus 3x plus 1. A lot of mistakes a lot of students make, when they expand, they forget some of the information, and so it becomes incorrect as a result. Okay, so we have f of x. X is negative in the bracket. So we have x squared plus x, -x in the bracket minus 1, which is equal to x squared minus x minus 1. And you can see right here that x squared is negative. So therefore, when you have a negative times a negative, it becomes a positive. And that's why you don't see that negative here again. But here, because the negative overrides the positive, therefore the x becomes negative. And then you have -1 here. So here we have negative f of x. So I have a note here that when you have a negative of a function, you have to multiply the entire function by that sign that you see out here. So the others are natural, so you didn't have to worry about that because you don't need to put a positive sign in front of the f, the function. But because this is a negative of the function, then you have to put that in the bracket, and then the entire function becomes negative. So you're faced with negative x squared plus 1 minus 1, which is the function. And then, and going back to what the function is, if you notice there's no value plugged in for x, we keep the function the way it is, but the entire function becomes a negative value. So all the values that were positive become negative, and that's why that's the solution. Again, if we go into another example, which is g, the function of g of x. So that equation is square root of x plus 2 minus 1. So let's see what that looks like if we put values for the function of of x. So we have square root of 7 plus 2 minus 1. So remember, inside your square root application, you always have to make sure you solve what's in your square root first before you can do anything else. And some people, when they rewrite information, they sometimes bring that in under the square root. That should never be brought in. Always remember to pay attention to the way in which your question is written, so you don't make that mistake. So now we have 7 plus 2, which is the square root of 7 plus 2, which becomes 9. And then you minus the 1. So you do that first, which is a 3, then you minus the 1. That becomes 2. Again, g of x, which is -1, same thing apply, -1 minus, -1 plus 2. And we already know that's very simple. So we have square root of 1 minus 1, and that becomes 0. So it's going to get a little bit more complicated. So here we have h of x. H of x is equal to x squared plus x over x minus 1. So here we have h of x when the value is 2. This one is not that hard. You just simply square the 2, then you add a 2. And the square of 2 is 4 plus 2 is 6, then 2 minus 1, which is the denominator. And then that becomes 6 once you solve. Now, when h of x is -1, same thing apply. You just square it, and then that -1 becomes positive because negative times a negative. And then you're still left with -1 in this bracket because it's not squared. And then when you subtract a negative from a negative, it becomes an increased value in terms of the absolute value. But remember that even though it's an absolute value, it's really a lower value as the absolute value increases. So now it's -2. And then when you divide a number by 0, the answer is always 0. Okay. So then you're going to go to this one, which is a little bit more, not as easy to do. So h of x minus 1, so that's the function. So we go back to our equation, which was x squared plus x over x minus 1. And you plug all the values or substitute all the values of x, right? And you're substituting that with x minus 1. And you have to expand. You do your expansion, which I showed in the earlier question. Make sure you do that first. Some people just square everything the way it looks, the way it appears, and then they end up with x squared minus or plus 1. That will be incorrect. You have to expand because this is a factor of the same value. So you expand, and then that expansion will become x squared minus 2x plus 1. And then this is just simply removing the bracket because the outside of the bracket is positive. So therefore, the value when the brackets are removed will be the same. And then again, when you remove the brackets, you have two negatives together. So it increased in the absolute value, but the value is lower. So now it becomes -2. And then here at the top, you're going to be collecting like terms. When you collect like terms, so you're gonna, well, obviously the x squared stands alone. Then you have -2x here and plus x here. That becomes positive, negative x, right? Which is why you have negative x here. And then the positive one and negative one, you don't have a value. That's plus 0. That's understood. And then the x minus 2 is exactly what we have here, which is why that's the value. Okay, so we could try a couple questions and see what we can get here. So we do have a question that pertains to graph, but I would assume that graphing is very self-explanatory, so we don't really need to do that. But let's figure out, again, just a reminder, what shapes are functions and which one are not. So I'm going to draw it on the board. So here we have this one, and I'm not putting any values. Is this a function or not? If you say, so I'm going to say function or NF, not function. So if you say NF, you're wrong. It is, sorry, if you say F, sorry, you're wrong. It is NF, it's not a function. And here we have another shape, which looks different from the ones that we did before. So is that a function or not? If you say it is a function, you're right. So this would be A. I'll just call this A, and I'll just call this B. So B is a function. So that's a function, okay? So let's try one that is gonna look different from the ones that we have done before. So let's just bring up the let's draw another shape. So is this a function or not? If you say it is a function, actually, I'm just going to leave that one. So is it a function or not a function? So let's see what everybody has to say in the chat. Okay, and then this one here is going to be a little different. Okay. Is this a function or not? Remember, we can do the vertical test, right? So I'm giving the answer away. So if we do the vertical test, which is very, very simple, you can do the vertical line anywhere. So if we do it here or here, then this one will not be a function. Because why? You have the same value for, you have it twice, the same value for y twice, right? So that's not a function. Because it's also half of a semicircle going this way. So that's why it's not a function. It's part of it is the same thing, right? Like that. So that's why it's not a function. Now this one, because it's going this way, this one is a function. And the reason is because if you do a vertical line, you don't see anything happening on either side. You can only have one value. So that's why this one is a function. So far we know this one is not a function. This one is a function. This one is a function, and this one is not a function. Okay. I have some questions that can be done, and you can find the range, the domains. And once we're finished these questions, then it's going to take us right into our transformation questions or transformation unit. So if, okay, let me just get that sorted out. So if f of x is equal to x plus 5 square root. So these are what we need to find. We're going to find A. We're going to find the domain. Find the domain. B. We're going to find the range. C. We're going to find the value of f when x is 2. We're going to also find the value of x when f is negative 2. We're going to find the value of f of 2x. And let's try f of x plus 1. Okay. And see what happens there. The good thing is you can always pause and then go back and try the questions. So if f of x is, let me just fix that because it kind of looks weird. F of x is equal to negative 2, 7 minus x squared. We're going to find the following. We're going to find f of x 2. Then we're going to find the value of f 0. F and make sure that the bracket is first, okay? And then D is f of x plus 1. And lastly, we're going to find f of x when 2x squared minus half. What is the domain? What is the range? And what is the value of x of x? What is the value of f when it's a half? And I'm going to put another one here. What's the value of negative? I'll just change that. Negative. Okay. So let's see what that looks like. And let me know what you think. Okay, so that's it for the review. And then we're going to go right into transformation in the next session. And I hope that this was helpful to review all the different items that we talked about. So we'll go back. We talked about functions, how you determine them. We talked about the ordered pairs, the equations, the graphs. We review the functions, how to solve them, and to substitute the values. Then we talked about identifying functions in graphs. We also talked about solving them, and we have a few examples here, and that's it. And I hope it has been helpful. So one of the things we like to do at DigiTutorials, we like to go very slowly because there are students who can't handle fast lessons. So if you are the type that this is too simple for you, then that's okay. But if it also helps with review, then that's good. But if you're the person or the student who needs more in-depth, step-by-step explanation, then this is perfect for you, because one of the things we do is to make sure that you walk away understanding exactly why you're doing what you're doing, and so you can grasp the concepts. So thank you for joining me or us, and look forward to seeing you next time. Have a good one. Bye.